Okay, so today's session, ladies and gentlemen, is going to be split into two parts. The first hour to an hour and a quarter is going to be geometry. Although I know we could spend 3, 4, 5 hours on it easy and still be awake afterwards. No, I'm joking. Then the last 45 minutes or so, I want to tackle almost the most important part of this whole week, which is how do I sensibly approach the rest of this year as a matriculant? Because going again with the curse of knowledge, but as teachers and as an experienced adult, I don't want to sound getting old, but yes, we kind of assume you guys have the skills we have. And that's not true, because I did a lot more studying than you guys did. So what I would love to do is impart some knowledge in how do I get myself to be on time. But how do I approach my studies, not just this year, but also the rest? As I said to you guys from the beginning, my end goal is not your matric finals. My end goal is the rest of your life. And this is the way you need to start thinking now. Because let me put it into perspective for just 1 minute. This morning I was having a conversation with one of my best mates. And we were talking I was talking with him and I was talking with his daughter. Was supposed to be in matric this year. But let me quickly just share the reality, and because most of you sitting here, rightfully so, is so fixated on what's going to happen in the next 5 months that you are losing perspective of the rest of your life. Because everything in the past year and a half has been, you've got to get good marks, grade 11, okay, so you can go and study it. All of you hopefully have applied already at like 5 million universities, okay? And then grade 11 is done, and then you start going to matric, and everyone's like, okay, assignments, portfolios, CATs, PATs, IORTs, and all of those things, and now you guys are like, okay, June exams sucked. I thought I was going to nail this, and then it nailed me. And as I said to someone the other day that stayed behind, if that is you, you are normal. If the June exam sucked badly, that is normal. I have had only a handful of matrics that I've ever taught that actually felt good after the June exam. So it's very normal. It's nothing to be depressed about. Okay? But ladies and gentlemen, if this is the day you were born, and this is the day that you are 6 minutes late. Let's say, ladies and gentlemen, this is when you hope to die. 72. Okay, now some of you are going, that's a big number, sir. Why do I use the number 72? Twofold. Number one, because my illustration works out better. But number two, the Bible, and please get this, I'm not pushing it down your throat. The Bible says that if you are lucky, you will live to 70. And if you look at the world, you kind of are lucky if you make it to 70. But nowadays, with medicine and all of the advances in the healthcare systems, you can say, you're South Africa healthcare. You haven't been up in Africa if you think South Africa's healthcare is bad, okay? You haven't been up in Africa. But 72 is a young age. Now more and more people are living to 80, 90, and in some pockets of the world, even 100 and further. Okay, because there aren't stuff that's killing us so rapidly like it was 100, 200 years ago. But let's not think about that now. Let's say you are approximately here. Let that sink in for a moment. By the time you finish matric, you have only lived, if I look at this, 25% of your life. The other 75 is still lying ahead if you make it to 72. So although it's good to be really fixated on this next 4 months, because this next 4 months is going to determine where you can go in life, that's the reality, that's true. It's not necessary, but it's not the beginning and the end of it. What you are going to do here is going to be what people remember you by. Or don't. I've met some of the brightest kids in my life, people that have studied with me, and they've become highly successful in their careers, and some of them less. But they're not making an impact. Because all that they were fixated on was matric. Getting a degree. I've arrived. I can go and work now. Ladies and gentlemen, if you want to make a real impact, if you want to fulfill your potential, you've got to know, although this is an important 5 months, it's not the end of the 5 months. And ladies and gents, I'm going to say something you're not going to like. Some of you, sitting in front of me, in the next 2 months, are going to get really bad news. So are you a prophet? No. But some of you are going to get news that you have not been accepted for maybe your first choice, or possibly even your second choice. I was speaking yesterday to a student advisor, and he said to me, one of the top student advisors in the junior tax, they're already starting to get knots on their stomachs because they know in the next 2 months they're going to have to call the students, send emails, and say to them, sorry. You got 85% average. Sorry, you cannot study to become a doctor. Those are realities. Now at that moment, you can throw everything out and go, oh, I'm a failure. I'm not going to do anything in life. There's 75% of your life that's still lying ahead of you. If you think about it clearly, there's still a lot you can do in those 75%. You don't have to, your life is not going to just go directly, I promise you. I know when I was your age. I see, here am I, this is where I'm going, and I expect I'm going to go, whoom. I know that. Start going, and then life takes me there. Then life takes me there. And then life takes me there. And in the end, I get there with the knowledge that I actually need when I get there. Your life is not going to go in a straight line. You've got to learn to solve problems. You've got to learn to say, what if the bad news comes? Let me feel it. Don't just try and ignore it. That's being idiotic. Feel the emotions, but use the emotions. If you get the good news, yes, but now I've got to make the best of it. You get the bad news, oh man, this sucks. What other plan can I make to still get there? That is going to be the secret to success. And you please don't come and tell me, sir, you don't know. Oh, I know. I've been told I'm too white to come and work at certain schools. Yeah? You didn't even look at your CV. Why? No, because we were looking for economic empowerment. We were looking for a BEE candidate. Did I get angry? No, I didn't. That was the beauty. Is I've come to realize that if a door closes most of the time, I'm not meant to be there. Can I tell you what I did? I looked at the guy who told me it. And I said to him, that's fine, I fully understand. I don't necessarily like it, but I understand that especially in the schooling system, we need top black candidates in private schools because we are getting more and more and more people of color that come and study at the independent schools, so they need. Can I tell you, it was the beautiful thing that happened. At the end of the conversation, that guy came and said to me, next time you apply for a job, put my name on your CV. I'll be a reference for you. Just by the way that I treated him after he gave me the bad news. And now I can put one of the top mathematics teachers in South Africa on my CV as a reference because of the way I handled the conversation. And a year later he came to me and said, well, a year and a half later he said, please apply for the job. And I looked at him and I had to say to him, sorry, but no, I can't right now. Not, oh, this is me being good. No, I was at a different phase. So please, if you get the good news, then you've got to say, I've got a responsibility. But if you get the bad news, start thinking, how else can I get there? I want to tell one more story. I feel like I want to tell the story. With the bad news, one of my students last week got 5 distinctions. Wonderful young man, an Indian man. Love the boy to bits. And I love the Indians, I really do, because whenever there's a trouble, whenever there's a problem, okay, let's fix it. Am I right? Yeah? Yeah? There's a need. How can we fill it? He didn't get accepted to South African universities because he only had 5 distinctions for medicine. So he got accepted in Turkey to go and become a doctor. Oh, that's wonderful, right? Then the earthquake happened. The earthquake happened beginning of Jan. Here is this oak. His whole life, he was aiming, I'm going to Turkey, I'm going to become a doctor. Earthquake happens, they close all of Turkey down. He can't even get hold of the university to ask them, are you guys actually still open? Eventually he gets hold of them and they just go, hey, sorry, we can't tell you when we will reopen. Our country has been torn apart. He's like, okay, Dan. He came and sat with me that later that week. He says, sir, I don't know what to do. I said to him, how else can you become a doctor? No, I can study here, look at there. And he started running with it. He got accepted into University of Ireland. He got accepted now in the university in New York, a university in Edinburgh. He got accepted into a university in Cyprus. He called me about 2 weeks ago. Sir, I don't know which of the three I've got to choose. Oh, what a problem to have. And he's looking at going into biomedical engineering. I hope and pray that he's going to get into it. I haven't heard from him. He said he'll call me and I'll follow up with him. But that boy had all the right in the world to go and sit in that corner and cry. None of the universities in South Africa want me. The one university I get accepted in is the flippin' earthquake. I'm just going to sit there and cry. He didn't stay there. So I'm imploring you, good or bad, choose right. Choose the right. It's not, you're going to feel the emotions. Everyone will feel the emotions. But make the right choice what you do with the emotions. If you can learn that in life, that's the basis of success. If Steve Jobs turned around when everyone in the world was telling me, you're flipping crazy, no one in this world would want to touch a screen to get a keyboard. That's what they told me. Everyone wants a physical keyboard. They want to feel buttons. That's what they told him. He said, you just wait and see. The people are going to love when they get a nice big screen where they can use the whole screen. You're crazy. I'll show you. The people that were crazy, or told him that he was crazy, are the companies that went bankrupt and had to be bought over by other companies. Nokia, BlackBerry. The only way they could survive was being bought over by other companies. But that guy took that negative feedback, the criticism, that you can't do it because, and he said, I will show you. I will show you I can do it. So please use the emotions right. Woo! Hello is done for now. Okay. I need to get back to the maths. Okay. Oh, man, sorry. Ladies and gentlemen, geometry, my big love in life. The biggest problem with geometry is threefold. Number one, toolbox is empty. If I ask you what the definition of a circle is, you can't even tell me. Now some of you are going, oh. Okay? Secondly, when you guys approach a problem, your toolbox is disorganized. So you try to say, okay, I want a star screwdriver. No. 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 Oh man. Let me give up. Let me move on to the next question. I don't have time. I'm seeing there's a yes sir, preach it sir, preach it. The third thing is the approach you guys use generally are wrong. Not you are wrong, your approach. So what I would like to do today is This is why I'm only going to spend about an hour on geometry. Because, number one, most of you wouldn't have done grade 12 geometry yet. If you're in a government school, you usually do it in the third term. Some of you would have done geometry, and that is also fine. But I can't assume it. Okay, so I'm going to look mostly at grade 11 geometry. How many of you have done grade 12 geometry? No? Oh, all of you. Oh, this is even better. Okay, so I am then gonna, unfortunately the things that I prepared is on grade 11, but I mean that's fine. I'm going to show you a few tricks with grade 12 geometry, and then we are going to look at the approach you take towards geometry. And I can guarantee you, and you can ask our cameraman back there, I laugh because he's like, "Sir, I still remember the way you taught it back then," when he was one of my students. And so what we're all going to do, first of all, is let's fill up your toolbox. Okay, so all of this that I'm going to share with you is in the booklet, but what I would love you to do is kind of take the booklet on the side, but get a separate piece of paper, turn it sideways so that it is landscape, and I would love you to just go through the theorems and understand the way that I divide the theorems into structure. Because Shane, what I'm doing then is I'm putting all my screwdrivers together. I'm putting all the hammers. I'm putting all the drill bits together. So that you can just quickly go, I need a screwdriver, star point, let me take it and run with it. This is the way I would like you guys to start organizing your toolboxes. So let's start with grade 8 to 10 geometry. So you can basically divide your page into 4 parts. Grade 8 to 10, and then circles. Okay? And we'll take back maybe a second page, and we'll look at the grade 12 stuff as well. But the grade 12 stuff is actually very, very easy. It's when they ask it when it's difficult. Okay. So, grade 8 to 10 is first of all lines. So, fun talks. I love to do quick little things, fun talks. Most of you would know fun. The talks, some of you will not have a cooking clue what that is. Okay? So, if that one and that one, corresponding angles. But remember, you've got to specify your parallel lines. That one plus that one is 180. Co-interior angles. Again, you've got to specify your parallel lines. That one is equal to that one. Alternate angles. And again, specify your parallel lines. That also gives me the first 3 ways of proving a parallel lines or set of parallel lines. Is I can prove an F, a U, or an N, then it gives me parallel lines. So learn to identify that. So when I tell you, prove it is a parallel line, you can go to your toolbox and say, okay, the parallel lines, I only have to look at 4 things to prove parallel lines. The F, the U, the N, all grade 12. That's the only ways we've got to prove parallel lines. Ooh. All of a sudden I don't have to look at everything. So this is also, and I'm going to say this, proving parallel lines. 1, 2, or 3. The T angles on a straight line. The O, 360 degrees. The X, vertically opposite. Then, ladies and gentlemen, I can think about triangles. Now we talk about one of the most important things, which is an axiom. How many of you have heard about the terminology an axiom? Some of you that were at the winter school or the summer school last year would have heard about the word axiom. Was there a summer school? Yes, there was. An axiom is something you accept to be true without it being proven. Have you ever proved that the interior angles of a triangle add up to 180? No. I've investigated it, I sucked at it, and my teacher told me, no, it's not 182, it's 180. Why? Because I say so. Am I right? That's grade 8, right? Now here comes a kicker. Hello, lesson number 2. Which things do you accept to be true without it being proven? Ooh. And the scary thing is you build your whole life on it. Is stealing right or wrong? You say it's wrong. All of you is like, so it's obvious. But what if I grew up in a household where my parents taught me to steal is the way to survive? Would I still say it's right or wrong? Huh? Then I would not see it as being wrong because that's the way I grew up. Your religion, your society, your culture teaches you things and you're not allowed to question it. And eventually you stop questioning. I say the example, but it's actually really funny. A lady makes roast leg of lamb. Oh, I love roast leg of lamb. But she got taught by her mom to always cut off this piece at the end. And her mom got taught by her mom to always cut off this piece at the end. And always when they made roast leg of lamb, they cut off this piece at the end. Eventually they went to the great-grandma. The little girl went and asked, Granny, why do we cut off this little piece at the end? You know what the response was? Because it didn't fit into the oven. Silly example, but how much do you accept to be true? And the scary thing is, ladies and gents, you are going to walk into a lot of things in this world where you are going to be confronted with people that don't have the same morals, ethics, values as you. And you're going to have that choice. Are you going to fight them or are you going to accept them? Unfortunately, in South Africa, I'm saying that with a lot of love to the black people, your ancestry has gotten it so down so right that the Sothos hated Xhosas and the Zulus hated Xhosas and the Vendas hate the Sothos. We won't want anything to do with each other. Am I right? But when I've worked with people I work with people in all the different cultures, and each of them have their own amazing strengths, have their own amazing abilities, but simply because of what happened 200, 300, 400 years ago sometimes, we can't stand each other. But if we just learn that you will bring something to the table I don't, so will you, sir. Hey, then what we can achieve together is going to be so much better. Woo! Sorry, I'm full of adolescence today. Hashtag sorry, not sorry. This is why I love geometry. I love geometry because it teaches me about the reasoning. And for those of you that are looking at going international, you have to learn before you go into a culture, what do they accept as their showing of respect? Disrespect. Because you will go and you will try and greet someone with a hand and they look at you and go, I'm not going to do any business with you. Now in my culture, that's disrespectful. I want nothing to do with you. That's how some of those businessmen are. So you've got to learn, you've got to study. What do they accept? That's the only way you're going to make it internationally. And I want to say this, I love it. It's one of the reasons why in the world internationally, Indians make the best CEOs in the world coming from India. Because in India, you've got all the different cultures coming together and doing business. So they learn to work with the Americans, with the Asians, with the Middle Eastern, with the Europeans. That's why the Indians from India are sought after as CEOs and as financial guys because they know how to work with different cultures. While the Americans they just think like Americans, most of them, not all. The Europeans think like that, but the Indians have gotten it right. Same with the Middle Eastern guys. They get it right, and that's why they get the big business. We as South Africans can learn a lot from them. Oh, let me carry on with math. Sorry, guys. Isosceles triangles. One of the 2 or 3 ways of proving sides equal to one another. The first thing, if they tell me prove AB is equal to CD, this is the first thing I think of. It shows me that I've got to try and get angles the same. Exterior angle of a triangle. Do not forget about this one. They love to throw it in. And then after you get to the exam and they expect you to know it. And you forget about it and afterwards you're like, this sum is impossible. But didn't you think of this? Oh, man. Now we get to circles. Divide your circle thinking into 3 parts. Learn to read words and attach meaning to it. That's how I organize my toolbox, sir. Is I read the word radius or center of a circle, and the first thing I think of is the definition of a circle. What is the definition of a circle? Oh, a series of interconnected points that are equidistant from a central point. Wait, sir. Say that slowly. Basically just that there are radii. And all the radii are equal. You don't have to know the fancy definition. But the thing is, ladies and gentlemen, don't just be happy with what it is. Be content to think where it leads. Oh, I must write that down. That sounds awesome. Oh, I must make a note of that. Don't be happy with what it means. Be happy with where it leads. I've got it on camera, I must be there. Michael, make a note there, the timing and everything. Okay. If I've got radii, it means I have isosceles triangles. First thing I look for. If I've got radii from a center, I might have isosceles triangles. Which means, again, I've got equal angles. Then as well, I go to theorem 1, 2, and 3. Theorem 1. Angle from the center to the chord. If it is 90 degrees, it bisects the chord. If it bisects the chord, it is perpendicular. Now, Cassim, why is this important? Why do you do this? Pythagoras, 90 degree. What about analytical geometry, champ? M1 times M2 is -1. What about SOHCAHTOA? Oh, sir, trigonometry. Guys, the moment I see a 90, those are the three things I think of. I see a 90, and I think of Pythagoras. I think about M1 times M2 is -1. I think about trigonometry. So why? Because we can ask it. And it gives me another tool in my toolbox. So do I have to know it? Yes, because you've got no idea what's coming in your finals. Guys, I'm not joking when I say this. 2 or 3 years ago, the IEB, but you don't write IEB. But you don't know what the examiner is going to do. They started off a sum as Euclidean geometry. Halfway through, they threw it onto a Cartesian plane and made it an analytical geometry sum. You can go and look, I think it was 2020 or 2021. Can they do that? Why not? Why? Because they can. Because they're having fun. We as examiners must have fun as well, okay? Now, ladies and gentlemen, we get to Theorem 2. Theorem 2, my favorite theorem, one of them. Angle at the center is twice the angle at circumference. Don't forget about the 3 special cases of Theorem 2. So there are 3 special cases. If I open your toolbox, it might go just butterflies. Some moths. Haven't used it in yonks. The first one looks like this. Use your fingers. Form the angle. Bring it together. The second special case looks like this. And this is the one they love to ask because they know you guys don't see it. Angle at center, twice the angle at the circumference. Use your fingers. Angle at center, twice angle at circumference. The third special case. Angle at the center equal twice the angle in the opposite circle segment. Don't forget about that special one. For this one, I want you to put a star next to it. Because that is the one that the kids miss the most. Theorem 3, which is a fan favorite in the exam. If I've got an angle at the center, and it is a diameter, there's a 90 degrees. It's just a special case of theorem 2. Angles in the semicircle. I see a 90 degrees. What must I think of? Are they going to ask it? Oh, I don't know. I don't know what's coming. I'd love to know, but then I'll in any case not take it. Oh, no, it's just like that. Okay. Next, I go to theorem 7, 8, and 9. Why do I skip theorem 4, 5, and 6? Anybody willing to put their whole reputation on the line? No, joking. Just anybody willing to give a guess why I skipped theorem 4, 5, 6? What is theorem 4, 5, and 6 about? Cyclic quads. Are they going to tell you there's a cyclic quad? No. That's why I skip it. Because I first look at what they give me before I look what is on the sketch without it being given. So theorem 7, 8, 9, I'm going to need the word tangent. Ladies and gentlemen, you cannot assume any line is a tangent. I've seen it. I've seen it, sunshine, where they draw a line and it looks like a tangent. And then you kind of go, and you solve everything. Second question, prove it is a tangent. And you go, oh man, I've spent 7 minutes. No, whoa, this wasn't a tangent. They've got to specifically tell you it is a tangent. Theorem 7, favorite in analytical geometry. Radius perpendicular to tangent. What must I think of when I see a 90 degrees? Pythagoras. M1 times M2 equal to -1. Trigonometry. And the thing is, this is where it usually comes out in analytical geometry. Because they're going to give you coordinates, or you can find coordinates, and then they're going to ask you for the length of or for the equation of the tangent. Theorem 8. Boom. Boom. If I've got 2 tangents from the same point, they are equal. Why is this important? Say again? Okay, but why is it important? Yeah, sorry, you're talking, actually you're 100% right. What I'm looking for is if I complete a triangle there, I've got an isosceles triangle. If this thing is connected to the center, I've got a kite. I've got a kite, guys. But also I've got a cyclic quad. Because the opposite angles add up to 180. These are the type of small little things that they love to ask. And if you see, it's like, oh, this is so easy, son. If you don't see it, it is hard. Okay. Theorem 9. Favorite. Tan chord. From this side, form the angle, bring it together. From this side, form the angle, bring it together. Use your fingers. Now, why is theorem 7 and 9 very important, especially theorem 9? Why is it important? So what do you say? No, you, yeah.
So because they like asking it.
Good. No, you guys are laughing, but that's right. That you're going to have to apply it at least 2 or 3 times. Why else? It's the only ways to prove something a tangent. Guys, if they're asking you to prove a tangent, you look at Theorem 9. If I can prove that this angle here is equal to that angle there, and it usually looks funky like this, it's not in a... And please don't be an idiot. Yes, sometimes I've seen kids being idiots. Prove that line is a tangent to that. They're like, but there's no circle, sir. They're like, I kind of know that. I kind of know that, but if I had to draw a circle, that would be a tangent. All they're asking for you to prove those 2 angles being equal. Or the other way around. If you can do that, it is a tangent. You're going monkey behind the mountains. I'm having fun today. Oh, I'm going to miss you guys tomorrow. Okay. You don't have to reciprocate that feeling, don't worry, I won't take it personally. Theorem 4, 5, 6, the last ones but definitely not the least ones. Last but not least, cyclic quads. Why do I put it last? Because I've got to go look for it. The other 2 I've got to have words. Words give meaning. But with these ones, you've got to go and look for it. Theorem 4, the butterfly angle. Please don't use that as your reasoning. That angle is that one, or that one is that one, or the bow tie. But Theorem 4, please, ladies and gents, have a special case you mustn't forget about. What is the special case? Anybody? Yes, okay, you two gents are on point. Haven't heard your voice too much today. Yes, sir?
Proves that it's a cyclic quadrant.
Okay, to prove it is a cyclic quad, but there's a special case of Theorem 4. I'm not talking about the converse. Yes, sir? Yes, but what is the special case? Yes, sir?
So it has to touch all the points have to touch the edges of the circle.
You are right. All of you guys are like, okay, it's got to be a cyclic quad. It's got to be in the same segment, but there's a special case of Theorem 4. Yes, sir? Thank you, sir. If I've got equal chords, the angles opposite them, the angles that subtend them are equal as well. Put a star next to that because they love to ask it, because they know you guys forget about it. Angles subtended by equal chords. I love the English. Afrikaans uitjies dat. Wat sê julle gebruik meneer daar? Meneer Clooney. Hoeke onderspan deur gelyke koorde. Still remember something about the Afrikaans. Okay. Second one, opposite angles are supplementary. So adding up to 180. Number 6, again one that's forgotten. That one there, if that one there is equal to that one there, or while it is, then it is because it is a cyclic quad. Then we've also got our 3 theorems to prove a cyclic quad. If I've got those angles equal, I can draw a circle around the quad. If the opposite angles are supplementary, I can draw a circle around it. So interestingly enough, are all squares cyclic quads? Yes, because the opposite angles add up to 180. But are all parallelograms? No, because we just know with parallelograms the opposite angles are equal. Not that they're 90, but they don't always add up to 180. Lastly, if I can prove that angle to be that angle, then it means I can draw a circle around those points. Now, ladies and gentlemen, before we go into practicing this, I please want to encourage you. Yes, sir, sorry.
Also, can you please repeat the fourth terms?
Which one? This one.
Yeah.
If I've got angles in the same circle segment, they're going to be equal. Why? Because they actually stand opposite the same chord. That is what theorem 4 says. Or I could draw the chord at the top. Then those two angles are going to be the same.
So can you explain the bisecting concept?
Which one?
So on theorem 4, you said something about bisecting.
No. Subtending, meaning standing opposite. So if those two angles are, or those two sides are the same, then the angles subtending them are also going to be the same. That's a special case of theorem 4. That answer your question? Good. Please, ladies and gents, go and study your proofs. I know it sucks. I know it's a pain in the patootas, okay? I know. But it is 6 marks you can score. So it's just 6 marks. That's 4%. That can be the difference between 78 and 82. Or 86 and 90. So, can you help me? Start with this one. Then you study this one. Then you study this one. I'm going to make this one 2 little stars. Then you study this one. And those are the 1, 2, 3, 4, 5 you've got to know. Now, I'm not advertising for someone, but I am going to tell you, if your teacher didn't go through the theorems with you, if you need someone to go through the theorems with you, please go and Google this lady. Jessica Ballantyne. Jessica Ballantyne goes through all grade 11 and 12 theorems with proofs, with examples, from beginning right through to the end. In her videos, amazing videos. I even use them when I teach this in my class, because she does it fantastic. Now, what is grade 12? Grade 12 is just very simple. Theorem 1 says, if I've got those sides to be parallel to that side, the proportions are the same. So A, B, C, D, E. So in other words, if BC is parallel to DE, then AB over BD is the same as AC over CE. But this I can also flip around, giving me the fourth way to prove lines parallel. If the proportions are the same, then the sides will be parallel. So that is your fourth way of proving lines parallel to each other. Theorem 2 is a strange theorem because you did it in grade 9. You just do it formally in matric. If A is equal to D, and B is equal to E, and C is equal to F, then triangle ABC is similar to triangle DEF, and this leads me to say AB over DE is the same as BC over EF is the same as AC over DF. Okay, that's grade 12. In a nutshell, that's all. Now, a word of caution. A word of caution, grade 12. Listen to me carefully. Theorem 1 does not have the power to relate that side to that side. Theorem 1 does not have the power to be able to relate the parallel lines to one another. If you want to talk about their proportion, you've got to use theorem 2. Be careful. A lot of guys go and say, oh, so the sides are divided in proportion, so BC over DE. No, whoa, 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 whoa. Theorem 1 doesn't relate those two to one another. Only theorem 2 can. Okay. Only if it's midpoint. There is a special case of this where if B and C are the midpoints, where we can relate them, but that's a special case. It's not general. Okay. Now, I'm done with talking. I'm tired. I've spent the past hour being funny and enjoying my life. Okay. I'm going to ask you to take one and send around. And I am going, the Afrikaner ook is just, I'll give to you now. Take one and send around. The Afrikaans guys, don't take English. Don't take English. Take one, send it around. Okay, the Afrikaans guys, please put up your hand. As you get it, please fill in the question marks. Okay, there's the right answer. Let me quickly just go. Boom. CEB is equal to X. That's what must be written in those first question marks. And in C, it says there, show question mark 1 and whatever. Just correct it for me, please. And I'm going to give you guys 10 minutes. Please do these sums for me. Okay, ladies and gentlemen, I know that most of you are not even close to being done. It's alright. Some of you are still stuck on question 1. Honestly, right, yeah, it's fine. So what I would like to share with you guys is, just for a moment, put down your pens and check me out. Gonna flex a bit, show you my mathematical prowess, with a bunny in the hand, of course. But the thing is, ladies and gents, can I tell you what is for me the big issue? Miss, can I tell you what's the big issue for me with geometry? Is you guys start with a bunny, and then you try and go, find with reasons 5 angles equal to x. And then you go to the sketch. And then you kind of check the sketch out, and then you kind of go, okay, let me go and read. Please don't. You are not going to have much success simply because you are wasting time. Okay, so what I want to share with you is the right approach, I believe, towards geometry. The right approach is a twofold approach. Number one, sir, I'm going to start digging through the rubble. I'm going to start digging through the dirt of information, and I'm going to take out of it the nuggets of gold that I need. Yes, I'm being poetic today, or a mathematician. Okay, so let me quickly switch on the lights. Let's stop all of this romantic stuff here in the front. In the diagram below, okay, I'm going to ask who loves to read and is scared of reading. Okay, miss, would you mind, please, on the mic, would you mind reading through it for me? Okay, please, I promise I won't make you look too bad. I'm joking. Just go for it. Okay, please read the information for me.
In the diagram below, O is the center of the circle.
Stop! Let's think what that means. There's a problem. A lot of you just go, oh, it's the center of the circle, hey, there's a diameter, blah, blah, blah. No, stop! You've hit a nugget of gold there. Now let's break it apart. If I read a center of the circle, I'm definitely not an art student, so my parallel lines are not parallel. Hashtag sorry, not sorry. O is the center. Okay? Let me go through theorem 1, 2, or the definition. Theorem 1, 2, and 3. So let's start there. If O is the center, I've got equal sides. Which means I've got an isosceles triangle. Okay? Now what I love to do at this moment of time is just make little notes on the side and go, that one there, because it is an isosceles triangle. Okay? I understand this. If you don't, make your own little side notes there. Next up, I look for theorem 1, 2, 3. Theorem 1. Do I have a line to a chord? Yes. But I don't know anything about that point, so I'm not going to do theorem 1. Theorem 2. Angle at the center. Doesn't really come together anywhere. So I'm not going to do theorem 2. Yes, miss? Yes, there is. I didn't even spot it. There. OC and OB come together here by A. So if that, for instance, is X, then that is 2X. Is that what you're referring to? Oh, you're referring to something. Oh, are you talking about maybe this side? Where's your special case for theorem 2? I would love to see. S1. Oh! Here and there. Wow, I did not see that one. Okay, so if you go there, you can come together there. Great. I wouldn't personally like to use it. It's good to see it. But this whole thing, but it's good to just have it there in the back of your mind. Thank you for showing me that. Okay? But well, let's rather say that is why, then that is too wide. Okay, you alerted me to something I didn't even see earlier. Now, theorem 3, I've got a diameter, but it's not coming together, so I'm not going to use theorem 3. Okay, miss, now you can carry on.
AB is the diameter of the circle.
Okay, let's stop. AB is a diameter. I've already kind of looked at that. I can't use theorem 3, so let's carry on.
Chord CS produced meets chord EB produced at D.
What the hell does that even mean? But what does it mean? Yes? Okay, it's continued, which means CSD is a straight line. And EBD is a straight line. That's important because otherwise I don't have exterior angles of a cyclic quadrant. If it's not a straight line, there aren't exterior angles. I know it doesn't feel like it's much use, but yes, let's carry on. Carry on, miss. Carry on. Carry on.
Chord EC is parallel to chord BC.
Okay, BS. So, that one is parallel to that one. Now, ladies and gents, I am going to rock your world. Most of you looked at the F, the U, the N, right? Did you look at grade 12 theory? Oh my hat. Ladies and gentlemen, don't forget that I can look at this over that is that over that. Heel. Ladies and gents, basically hulle vra dit elke eksamen en julle vergeet om al voor te kry. You forget to look at it because you're so fixated on the F, the U, the N that you forget to look at it. And then in question 3 and 4 they ask you ratios and then you guys sit there going, what? Okay. So first of all, let's look at the F, the U, the N. I've got an F here, so that angle is that angle. Corresponding angles. At the top here, that angle there is that angle there. Also corresponding. If I look at alternate angles, it's going to be B2, and this angle there, but it's not even labeled. So I'm not really going to look at them. If you don't know why this one here, remember it's at the top as well. And if you still don't see it, turn your page around. I'm not joking, turn your page around and you'll see the F from the top. You've got an F here by CSD, S2 and C2 and 3. Okay? I don't like to work with co-interior angles because there aren't values. There is no alternate angles that's of use to me, so I'm going to stick it there. I'm going to leave it there for now. Have I gone through all the theorems? No. But what about cyclic quads? Have I looked at them yet? No, so I've got to look at them. So I've got a cyclic quad here. That one there is that one there. Theorem 6. Okay, let me rather first go Theorem 4. I don't have a bow tie. Theorem 5. I don't have values, so I'm not going to use Theorem 5, but Theorem 6 I'm going to use. Because then again, I can tell myself that that one there is that one there. Exterior angles of a cyclic quad. Ah! I'm looking in your thoughts. So there's another cyclic quad. Yeah, there is. The other cyclic quad, I'm going to color in. Where I can use Theorem 4. And again, now Theorem 4 is going to tell me that that angle there is that angle there. So 2 dots is going to be Theorem 4. I'll get to that cyclic quad now. Just wait a moment. B1, so this one here, let me start being creative. Z and Z. So Z as well is with Theorem 4. If we look at another cyclic quad, where? ACS, ACSB. Wow. Okay, so I've got another cyclic quad. Oh my flippin' hell. S2 and A. Wow. Yes, sir.
So, you see, so are you allowed to say like construct line OE to form a radius so that you can say OE is equal to OC?
Okay, can I quickly ask you, sir, are you in a government school or in an IEB school? And I'm asking this for a reason. Which one? Then don't construct. IEB schools, there will be one question that they expect you to construct. Government school, they've never asked constructions except if it's in a formal proof. So it's not that you can't, but they don't expect kids to construct in government schools. Okay, so not wrong, but you might be trying to go to Cape Town via Durban. Yes, miss?
So can you please make it clear which elements they would require experience by?
Okay, for the IEB schools, it's a good question. How do I know I've got to construct? They usually make it flippin' obvious. Like they leave out a chord and you sit there and you think, but if this thing just had this chord, then I could use Theorem 9, or I could use Theorem 3. And it's usually one of the last questions in the paper. So it's really obvious. You're like, if only. Oh yes, but I can construct. Boom, 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 it works out. But if you're in a government school, I really advise you to look past construction except if it's a formal proof. Yes, sir, your hands up.
So if you do construct, does it actually mark it as you
No. Well, the thing is, I'm telling you now, the person that gets it will most probably just look at this and go, oh. Okay? Because I've never in 20 or 30 years have seen them ask it or expect it at all. The IEB came about 5 or 10 years ago and said, one question that requires construction, kids must be aware of it. So they made the kids aware of it. And the teachers. So we teach it actually, or you're supposed to teach it. Okay, at least you guys hear now about. But please, if you feel the temptation, resist it. Okay. CO and O and AC are joined. So they're just connected. If CB is X, okay, so let's quickly analyze. I've got X. I have 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 X there. Okay, I've got X there as well. C1 and 2. I've got C2 and 3 being X. I have X here. So I've got 1, 2, 3, 4, 5. Ladies and gents, Kutlanu, did I look at the question? Have I looked at the actual question they've asked? Have I actually answered the question? Ta-da! I haven't even looked at the monkey, sir. I haven't looked at what they asked, but I've actually answered the question. If you can learn to do geometry this way, guaranteed you are going to get 70 to 80% of the questions, even before you look at the questions. And I've been doing this for many years. I've been doing this for many years. Now, they ask me to prove that triangle DBS is isosceles. Now I start looking at the monkey behind the mountain. And I start asking myself, how do I get something isosceles? So I've got to get either the lines equal or the... But I already have the angles equal. So I've proven it. You're just going to tell them, well, S2 is X, proven. And you're going to say B3 is X, proven. Therefore, S2 is B3. Therefore, it is an isosceles triangle because sides are opposite equal angles. Yeah? Yeah, but which one are you trying to prove? You're trying to work in triangle BSD. Okay? Now we get to the C part, which is weird. Right? How the hell do I get C1 and C3 equal? Did you get there? Yes. How did you get there? Yeah, please. I would love to hear that angelic voice.
So you already proven that that C1 and C2 is equal to C2 plus C3.
Okay, so let me just quickly clear up my sketch a little bit here. Okay. Now, let me quickly just enlighten you guys. What have we proven? C1 and C2 is X. Why do I go there? Because that's the monkey. I want to prove C1 equal to C. Now I ask myself, what do I know about C1? And what you're saying is right. That C1 plus C2 is equal to X. Yes? And
C2 plus C3 is also equal to X.
So in other words, I'm going to take the long road because curse of knowledge, okay? Both of these sides are equal to x. So C1 plus C2 is C2 plus C3 because they're both x. So the C2's can cancel each other out, leaving me with C1 equal to C3. Oh, jong, daar raak 'n bietjie lank hierso. Okay. Now, we get to the last question. Show that BOCD is a cyclic what? Okay, so now, here I'm starting to go monkey behind the mountain. I want to prove, okay, let me get a different color here, sorry. Red. BOCD. I want to get those ones. I want to get that to be a cyclic quad. Now I've got to ask myself, what do I have already? Or let me first ask myself, how can I do that? Let's forget about what we've got. Let's go and look. Again, what am I doing? And please get this. I'm opening my toolbox and I'm asking myself, how can I hit the hammer into the wall? Or the nail into the wall? I am only taking out the hammers. I'm choosing to leave all of the screwdrivers in here. I can maybe try this one, but that's going to struggle. I can look at theorem 4, 5, or 6. I'm throwing out all other knowledge that doesn't help me. Now if I look at BOCD, there is no butterfly there. Proving them to 180 is going to be a toughie. So now I've got to start thinking, maybe, just maybe, I must try theorem 6. So now I start asking myself this question, which angles must I get the same? That angle there. That angle there. Okay, that's my only option. Now I start asking, if I can do that, do you guys agree with me that's a cyclic quad? Now I must start asking myself, what do I know about angle AOC? So that is x up there. That is x down there. So that one there is 180 minus. Okay, so let's stop the bus. That's 180 minus 2x. If I can just somehow, magically, get angle D to also be 180 minus 2x, have I answered the question? Well, let's look what I've got. I actually have B2, or I've got B3. That is x down there. That is x down there. That is 180 minus. Magic! Yes? Say, yeah, that will give me 5 marks. How? Remember, you already have A to BX. You already have C1 and 2 to BX. So you would get angle AOC 180 minus 2x. interior angles of a triangle. Angle D, 180 minus 2x, interior angles of a triangle. Sorry, that's 3 marks. One for the AOC, and the reason. Angle D because you're repeating the process. Therefore, it's a cyclic quad. Why? The exterior angle is equal to the interior opposite angle. Yes, sir. You can. I love it. Remember what I started this week with. Find different methods. So if you've got COB to be 2x exterior angles of a triangle, and then go angle D is 180 minus 2x, and that's both. Find a method that works for you. If you see it, you go for it. But the secret is getting from what they ask you, what do I need to do? That's the secret. Yes, miss?
So I found a different way.
And I love it.
I'm using B1
B1 equal to C3. That can work just as well. Okay? I love it. Guys, this is the beauty when you start seeing things I don't even see. When in a matric exam, please get this. When you get a sum like this, there's sometimes 7 or 8 different ways. I've marked matric exams with these sums, there's 7 or 8 options. If you go this route, if you go this route, if you go this route. If you've got a teacher that's worth their pound in, then they will hopefully have all of the options when you're writing prelims. I'm hoping so. Can't guarantee it, but I'm hoping so. But even in that, ladies and gents, your final is the most important one. Okay, short. Time is going by way too quickly. I want you to go to the last page. And I want you to please do this sum. I'm going to give you 10 minutes to do this sum for me, please. It's, I think, on the last page. This one came out nice. In the diagram below, O is the center. 10 minutes. Please don't look at the question. Just dig through the information the way I showed. Please. Okay. Ladies and gentlemen, some of you, if you are quick on the uptake, then this is actually quite simple. But I'm asking just for patience. This sum is going to be our last sum I'm going to do with you guys. But then I'm going to show you what I've already done for the junior tux. So let's quickly go through this and then I'll show you, because I didn't know that most of you did grade 12, then I would have done that as well. I would have done it. Assumption is the mother of all screw-ups. In the diagram below, O is the center of the circle. So automatically, I've got equal sides. It's not going to help me in this case, but I must just know it's there. I can't apply theorem 1 because I don't have a line to a chord. I can't apply, theorem 2 I can't really look at, but theorem 3 I can. Okay? There's a diameter, so I've already applied it. HU is a tangent. So if I think about tangent, theorem 7, 8, 9. So first of all, from here, W1 is T. From this side, that angle there is equal to that angle there. If you don't see it, use your fingers. Going up, form the angle, bring it together. Okay? Next up it says, okay, I can't use theorem 8 because I don't have two tangents. Is this thing on? Yeah, it's on. Okay. And chord SW is produced, so it's just extended to V, and VU is, sorry, this one is not drawn right. I see now it should be a straight line, my apologies. To US. So I've got a 90 here. Now let's quickly stop the bus before we go to the question. Is there a cyclic quad in that triangle? No, so I'm not going to look at theorem 4, 5, 6. Okay, look at my systematic thoughts. And that's what I would love you guys to do, is don't just rush. Take time. Enjoy the journey. Okay. Prove that WTUV is a cyclic quad. Oh, but that's easy, sir. If I can prove that one to be that one, or that one to be that one, or that one to be that one, or that one to be that one, then I know it's a cyclic quad. That's theorem 4. Theorem 5, if I've got the opposite angle supplementary, then it is a cyclic quad. I don't want to use that, but I do want to use that 90 and that 90. Oh, I've already proven it, so yay! And now I quickly go and I say, okay, prove that VU is a tangent, right? No! Ladies and gentlemen, please, 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 please. First thing, what do I have now that I've got a cyclic quad? All of a sudden, I have now that W2 is equal to T. I've got V1 equal to U2. I've got U1 equal to that. I've got V2 equal to that, because this is a cyclic quad. In the matric work, they are going to try and catch you out, because then they ask you, prove this thing similar to that thing. And then you're going to need the angles that you've gotten equal from proving it is a cyclic quad. Do not forget to look at it. Even if you went quickly through this, oh, this was so easy, sir. Okay? Let's quickly look at this next question. Prove that VU is a tangent to the circle passing through VTS. So if I got a circle through VT and S, so if I can get V2, sorry, is that V1? Sorry, I swapped them around, V1 and V2, my apologies. If I can get V1 equal to S. So if I can get V1, so I love to write this. Here's a little tip. Take a tip from a fool. I've been a fool many times in my life. What do I need to prove? Write that for the examiner. I need to prove V1 equal to S. Miss, can I tell you why you must write that? Because even if you can't do the sum, they still give you 1 mark. Guaranteed. Even if you can't do the sum, the examiner gives you a mark for knowing what you need to prove equal. I've seen it every year. Kid has got nothing else, but they know they've got to prove V1 equal to S. Give them a mark. That's 20% instead of 0. Woo! Nice! Nice! So now I've got to ask myself, what do I know about V1? What do I know about this? Oh! Ta-da! I've proven it. Not difficult at all. But that's only if your toolbox is organized. Good luck if your toolbox is empty or disorganized to try and do geometry. Now, imagine, ladies and gentlemen, is there any of you that are looking at studying ACSI, actuarial sciences? Some of you going, look at that guy. When we walked in the first day of ACSI, now please, it's not much different from engineering. The engineering just doesn't do the background maths, but they still do the same maths. They just don't do the proofs, but they still do the maths. The professor walks in and he says, in your first semester or your first exam, you are going to write about the same amount of maths than you did in your whole grade 11 and 12 in one subject of your 7 or 8. We laughed at him, we're like, yeah, whatever. For our exam, 470 pages in our math textbook to study for calculus. That's the same as your grade 11 and 12 maths textbooks put together. Ladies and gentlemen, you cannot afford to have a disorganized toolbox when you get to university. You are going to run out of steam long before you've exhausted all the tools that are available. So what do I want you guys to do? First of all, I've been really awesome the past few years, and I'm so humble about it. I would like you to go, ladies and gents, onto juniorturkey.online. If you don't know about juniorturkey.online, I would like you guys to go on there for your own sake. We've spent the past 3 years developing content for you. Mahala, for free, for nothing. This is funded by UNICEF, and we've spent upwards of 4 or 5 million on this platform. I'm not exaggerating, that's how much we've spent. And we are busy exploring, or not exploring, expanding this platform. We've got another few million for the next 2 or 3 years to expand it. So once you've registered and you go, for instance, to mathematics, that's my baby. But if you look carefully, ladies and gents, there's also accounting. There's life sciences. There is English and physics. So if you go to maths, which is my love, my baby, my pleasure, okay? And you go, for instance, to the mathematics classroom. I know I didn't do grade 12 geometry, but I'm not seeing it as the end of the world, because there, ladies and gents, you have a whole chapter of videos. All of these links on the left are videos. Revision of the theory, what we did today. Grade 12 theory. Exam questions. Every single one of those is a video where I take you step by step. How do I solve grade 12 theory or grade 12 problems? Here is an hour worth of videos. One video, a live session. I'll tell you guys a story about this, but yeah. Then at the bottom, you've got revision notes. You don't need it, you've got the whole booklet. But ladies and gentlemen, the beautiful thing is then you have a full 10 questions that come from previous, or 9 questions from old exams, as well as the memo, fully worked out, step by step. How do I get to the answer? Now, these are not the only way you can get there, but it's a way of showing it. And again, it is mahala. It is for free, it's for nothing.